Okay, so you sent over some really fascinating stuff today. It's about using calculus concepts well, for growing plants better. Sounds pretty specific.
Yeah, it does, but it's a fantastic example. We're looking at differentiation and integration, those core calculus ideas applied to something really hands-on.
Exactly. So our mission for this deep dive, based on what you shared, is to unpack how these math tools actually help plants thrive. And this is really for you if you're maybe, grappling with differentiation or integration right now in a class.
hmm
It shows a powerful, kind of unexpected real-world application straight from your material.
Absolutely. What's really neat here is seeing the math jump from like abstract theory into something practical, making a plant grow better.
Mhm.
The main thread we picked up from your sources is that understanding these concepts, rates of change, accumulation lets you manage resources smarter. Water's a big example they use.
Right, okay. So the material points to two main ways calculus gets involved here. First up was integration. I thought that was interesting, using it to figure out a total amount of something over a period of time, like total water the plant actually used.
That's exactly it. If you know how fast a plant is using water at any given moment, that's its rate integration lets you, well, add up all those tiny moments over time. You sum it all up to get the total volume of water consumed. It's kind of like tracking your spending bit by bit each day to get the monthly total.
Ah, okay. That makes sense. So you get the big picture on water usage.
Precisely. And that total figure is pretty crucial for planning efficient watering, avoiding waste.
Okay, got it. And then the material switches gears a bit to differentiation. It says you use that for optimization, like finding the absolute best conditions for the plant.
Yeah, optimization, that's the key word. Differentiation is all about finding rates of change, which helps you pinpoint maximums or minimums, peaks and valleys, sort of.
So how does finding a peak apply to a plant, practically speaking?
Well, imagine you have a mathematical model, maybe based on the sources,
Mm-hmm.
that describes plant growth relative to something you can control. Let's say amount of light, or maybe fertilizer. Differentiation lets you analyze that model to find the point where the rate of growth is highest, the peak of the growth curve, essentially.
Okay.
Or maybe you want to find the point where you get the most growth for the least amount of water optimizing efficiency.
Mm-hmm.
It helps you locate that sweet spot.
The optimal point for whatever you're trying to achieve, based on the principles in the material you sent, it's not just about maximum growth, maybe minimizing waste too.
Exactly. It could be about maximizing yield or minimizing resource input for a certain yield.
Yeah.
Both are optimization problems.
Okay, so let's quickly pull this together then, based on your sources. Integration helps measure the total accumulation, right? Like that water example, essential for resource tracking.
Yes, it gives you the sum total over time.
And differentiation, that's more like the fine-tuning tool for finding the ideal conditions, the best point for growth or efficiency.
That's a good way to put it. It's the tool for optimization in this context, for hitting that peak performance or efficiency.
It really is kind of cool seeing how these, potentially abstract math concepts from class can directly influence something so physical, like growing a plant.
Absolutely.
Huh.
It underscores that math isn't just stuck in textbooks. It genuinely helps solve problems and get tangible results in fields like agriculture or even just home gardening.
Yeah, or environmental science, I suppose.
For sure.
So maybe a final thought for you to chew on. As you go about your day, look at the systems around you, could be anything. Where else might these fundamental calculus tools be working quietly behind the scenes, adding things up over time or finding those optimal points, something to keep an eye out for?